Hi there, this is your favorite non-Indian math channel, and let's see how we can do this infinite sum. So first of all, this sum looks like n. Okay, so I have 1 over 4n squared minus k squared in square root, and k's are going from 1 to n. K goes from 1 to n. Let's try to see if I can make it look like a Riemann sum. So I need to take any term that looks like 1 over n minus something, okay? But instead, simply I can just take 1 over n out. It could be 1 over m minus 5 too, but it doesn't make sense here. So if I take 1 over n out, which means if I take this square root into n squared parentheses, so this is going to be 4 minus k squared over n squared. So I can just say k over n squared. So this is just equal to my sum from 1 to n. And now this is indeed Riemann sum, because I'm starting from, if I put k is equal to 1, this goes from 1 over n, 2 over n, up to n over n, which is just 1, and I'm starting from 0. So this is just right hand side summation, okay? So I can say if I take limit as n goes to infinity, let's also put limit here, n goes to infinity, this is gonna be the integral. So I partitioned between 0 and 1, I have n pieces and I have 1 over n here. So this is from 0 to 1, 1 over 4 minus, so I have my k over n's here, so this will be x, and I'm squaring it because I have this square here, dx, and I have this square root. Well, this is just a regular integral. Normally we know that if we differentiate arc sine x, this is an elementary integral. This is going to be 1 over 1 minus x squared in the square root. So here if I substitute x is equal to 2u, it's going to give me arc sine of 2u, but it's going to be arc sine of x over 2. Okay, so this is arc sine of x over 2 from 1 to 0. So if I put x is equal to 1, I know that sine of 30 degrees, which is just pi over 6, is equal to 1 over 2. So this is pi over 2, pi over 6. And if I put x is equal to 0, sine of 0 is 0, so arc sine of 0 is equal to 0. So this is just pi over 6. And this is my answer.